Mrs. Eaton here again. I'm coming to you with a little bit of clarification on your 1.6 assignment. As you'll see in this picture, we're going to look at the warm-up where you are identifying what is an atom, what is a repeating atom group, what is an extended structure, and what is a molecule. And I think that this was very confusing for lots of you guys, so I would love for you to go back and check if you did not get this correct on Amplify to redo it and turn it in again. But we're going to talk a little bit about it. So, in case you don't remember this little box set from school, I'm going to use these to help along the way. So, the first thing that we're looking at is an atom. And every one of these, I have like lots of structures we're going to look at today. So these are the same, and then these ones. But every one of these, you can see they have like different numbers of little holes in them, but every one of these structures represents an atom. So this is an atom of carbon. Let's see, this one is going to be an atom of oxygen. This is going to be an atom of chlorine. So these are individual atoms, or they represent individual atoms. And if you don't remember, we talked about our periodic table of elements, right? This has every one of our atoms. So when I talk about hydrogen, we can look, and that is on my periodic table of elements. I said we're going to look at carbon. So carbon is right there, represented with a C. We're going to look at sodium, or we're going to look at potassium. So potassium is here. Its symbol is a K. Chlorine is over here. Its symbol is a Cl. So every atom is on our periodic table. These are individual, like I talked about. If you didn't watch my video yet already, there's another video about atoms and molecules. There are posted YouTube videos about atoms and molecules, so we know every time an atom exists, it's on here. It's always the same. Atoms are always the same, and they show up on our periodic table of elements. So those are just our individual spheres. One dot, one ball. This is just one atom. Then we can have repeating groups of atoms. So this, for example, we talked about methane, right? We've talked a lot about methane when we talked about it on the planet Titan. And so this is a repeating atom group. This is also a molecule, right? And so I can have lots of these. And if I have multiple of these, right here I have two, I have repeating atom groups. This looks identical to this, right? They're exactly the same because a molecule of methane is always the same. A molecule of methane is made up of one carbon atom and then 4 hydrogen atoms bonded together. I can also have other types of repeating atom groups. So this represents a potassium chloride. So this and this, right, we can tell that they're exactly the same. And here we're going to have these sort of stacked next to each other. And we're going to have repeating sections of this. And I'm going to go into that a little bit more. All right, so here we have a drawn out methane molecule. Same as this thing, right? They both have a middle carbon and then 4 hydrogens around the outside, like we see here. And this is a molecule that covalently bonds. And so what they do, we have these chemical bonds here. Those are those little lines. And these kind of represent shared electrons. So we know electrons are negatively charged, and we know in the middle of every one of these atoms, they have positively charged protons. And they share electrons, and that's what's happening in these bonds in a covalent molecule. And so here we see shared electrons. And then the end of this, these are neutral, like neutrally charged molecules. So this molecule isn't going to be attracted to any other molecule. These molecules aren't going to be attracted to each other really. We know as they like cool down and move slower, right? They change phases, and we know they can go from a gas where they're moving really fast, and then they get a little closer as they become a liquid, and then they get closer as they become a solid. But that's just based on how much they're moving. They're not actually attracted to each other. So we don't see any attraction here outside of our molecule. Right in here, there's lots of attraction because they're sharing electrons, and they both really want the electrons, and so they're sharing electrons, and they're really attracted to each other as this molecule. And then outside of the molecule, they're not as attracted. And that is very different than ionic bonded atoms that we're going to talk about next. So this is a different way of bonding. So when I look at this picture, I can see that I have lots of potassiums, right? K represents potassium. And I have lots of chlorines. But now I've drawn them with charges. So potassium, it actually gives away one of its electrons. It doesn't want it, it gives it away, and so if it loses a negatively charged electron, it becomes positively charged. And then chlorine, it really wants to gain another electron. So somewhere it finds an electron, maybe it's from this potassium, maybe it's somewhere else, but then it becomes negatively charged. So positive and negative things are attracted to each other, right? So this potassium is attracted to this chlorine. But this chlorine is also attracted to this potassium, right? Because this has a positive charge and this has a negative charge. We know we can stack lots of magnets up against each other, just positive and negative and positive and negative and positive and negative, right? And so that's what happens in this extended structure, right? So I have a positive, and then it's surrounded by some negatively charged things that are attracted to it. Here I have another positive potassium, and it's attracted to negative chlorines. Positive potassium, negative chlorines. And this chlorine, right, is attracted to these positive potassiums. So we've talked a ton about how positive and negatives are attracted to each other. And so this, I could just keep building this out, right? I can add in more and more potassium and chlorines, and it just gets bigger and bigger and bigger, and my extended structure gets bigger and bigger and bigger. But I can look at it, right? And this here is one repeating atom group. And then here we have another repeating atom group, and another repeating atom group, and another one, and another one, and another one. All right, I hope that helped with your 1.6 warm-up, where you're filling in what is an atom, what is a repeating atom group, what is an extended structure, and what is a molecule. So make sure you go back to Amplify, check that warm-up. I've left comments. Fix it if you didn't get it correct, and resubmit. Yeah, and like always, like this page, subscribe, comment, click the link below.